Very good evening, guys. So, yeah, today's session is about something that I've been looking at. For a lot of people asking up, sir, how can we do something on networks? So, yeah, today we scheduled an exclusive session on the two topics that are very interesting in IT. We will discuss that. I will take all your questions also. Let me run through both these chapters in the first place. Of course, then after we do that, we can go with the live. Davis, Sagar, Srija, everybody, hi, good evening. So, let me go ahead in the beginning itself and tell you that if any of you guys in the new syllabus, I don't think this session is any relevant to you. So, you guys can continue doing what you want to do. And the guys who are dealing with the old syllabus, information technology paper, we're going to revise chapters 3 and 4 through this live session right now. More people coming in. Prithvi says hi, all of you guys saying hi, all hi. Uh, so the new syllabus, guys, we will come back with a session on EAS as well. Uh, Abhigna says, sir, please do videos on ST. What is ST? You mean SM? Like, I'm not sure. Priyanka, just be clear. ST, what is ST? Um, then the others, okay, so what we are looking at here is about chapter 3. Let me not waste much of a time. So, uh, today whole life is not relevant. Yes, whole life is not relevant, Srija. This is exclusively for the old syllabus. We will come back with new syllabus for all those who are in the new syllabus. Don't worry, we will come back on exclusive sessions. So, otherwise, others who've just walked in, right? No problem. We will catch up very soon on the other topics as well, right? Please do videos on SM. Yeah, sure, we will be doing it. So all you guys watching there, let's go ahead. Let's look at the IT perspective for the old syllabus. Now, no panics. A lot of people have been asking questions in the past, so do not worry about this. Uh, Let me go with some of the points that we are discussing in the chapter 3, which is about telecommunication and networks. Okay, so let me be a little favorable on to what we are discussing here in the telecommunication and networks portion. So we have few topics to be discussed. The first one talking about the components of a network, or in other words the network configuration as such. What exactly is a part of the network, we're dealing that. And then we will be discussing classification of networks. Then we will be discussing about network structure, wherein we talk about network topology, network modes, network topology and network transmission, let's say. And in that we are going to discuss about the modes and all of that, transmission modes, transmission techniques and transmission technologies. This is what the basic thing. And then of course I will also give you a brief about network security. Okay, this we will discuss. And then of course what I'll not be discussing in this chapter is about e-commerce and e-payments. I think those topics are simple. E-commerce, internet, internet extranet, intranet, please take over. And of course e-payments and all that. Just so this is the broad coverage of this chapter, right? But these three topics are way too simple to be discussed: e-commerce, internet and e-payments. So go for it. Network, the other four topics: components, classifications, topologies and security. We will discuss them now in very clear thing. Sir, please, okay, wait, let me take a couple of questions here. So, what is network computing? Network computing. Okay, we will be discussing network computing as well. Now, which part of the topic are you asking it from? Bala Subramaniam. Network computing with example, like in the sense you want to know the whole picture of how the network works. I'm going to deal with it. Krishna, please explain flowcharts. Krishna, two videos are there of flowcharts. You can check it with my name. You will have very clear idea of both those. Both the videos are available. Flowcharts by C. Harish Krishnan. If you just can search that on YouTube. You will find two videos, part 1 and part 2. Both of them are very clear explanations of the whole flow charts. Okay, so yes, let's carry on. Let's go ahead. I'm going to start with the first topic here right now is about the components of network. So how do we go about discussing the components of network? Let us see that. So let me move on here to a blank slide. So how is it? Multi-tier architecture, yes, okay, don't worry, we will get to all of that. Each part will be discussed right now. Okay, let's start with the components of network. Okay, components of network. Okay guys, what are the components of a network? See, let me draw a structure first. Let me try to help you with the understanding, and then we will go and talk about each of them. See, basically, let's say here there is a computer. Okay, there is another computer somewhere here. This is computer 2, this is 1, and let's say this is computer 3. Now, fact of the matter, how are they going to be connected? The collection of computers only knows network. So, computer 1 can be connected to computer 2 using wires. So, I'm using this to represent them as wires. And then they can also be, I'm using a dotted line here so that I can just call them wireless. Okay, so we have a computer. Basically we have nodes. What are nodes? Nodes are endpoints, right? The beauty of using this stuff, you can change colors. Okay, let's go with it now. So this is a wired or a guided communication path. This is an endpoint, that is a node to which a computer is connected. You can as well connect printers or other peripheral devices. Okay, then this piece, the dotted lines, I'm talking about wireless or unguided. So now if you look at the summary of what are required to be connected, see, you need nodes and endpoints which are called as terminals. So there are 5 components in the network now which we are talking about. We will be considering the 5 components, and 5 of the components that is talking about. First thing I will be talking about is the terminal. That means the endpoints here, these are all terminals to which you can connect to. These things are terminals. Then the next thing that we are talking about are the telecommunication channel. Means either it has to go through a wireless or either it has to go through a wire. Okay, so it needs to be either of these. Then we have telecommunication processors. Okay, telecommunication processors. Then we have computers, printers, other peripheral devices, all those computers, printers, and most importantly, if all of this have to work, we need a network operating system or a network OS, right? That is what is required in terms of what you will be seeing in terms of these 5 components. Now I want everybody to properly watch out onto the screen as to what this is, because once you load this picture in your head, right, once you load this picture on your head, things are going to get way more easier when you revise. Okay, so this is the network picture that you see on screen. Now the whole picture, from one computer to another computer, how can they be connected? Either through wire or wireless. So this is called media. Telecommunication media, they are called. So wire and wireless, 2 parts to the story. Wired media and wireless media. We have computers to connect on each end. We have terminal devices to connect on each end. And this is how they will be connected in terms of what they are. Now, so terminals and computers, I don't think I have to explain. Now what the other 3? Telecommunication channel, telecommunication process, and a network operating system. These 3 things are there. So let's move on in talking about what is a telecommunication channel. Telecommunication channel. So if we are talking about a telecommunication channel, again What do you mean by telecommunication channel? Either it should be a guided media or unguided. It's a guided media or an unguided media. What about guided media? A guided media is something that uses wires, and unguided media is about wireless. Now, what is this wires and wireless media? Three types of wires emerge. Okay, three types of wires, they clearly emerge. What are the three types of wires that we say? Twisted pair of wires, twisted pair, coaxial cable, and fiber optics. And when you talk about wireless, you have terrestrial, microwave, infrared, radio waves, the longest, and then we have microwaves, the shortest, and we also have the last one, which is terrestrial, microwave, infrared, radio wave, microwaves covered, right? Then it's a communication satellite. Okay, so guys, either you use these 5 mediums which are wireless. So for all these 5, they use the atmosphere as the medium. Okay, they use the atmosphere as the medium. While in these 3, they are wires. Twisted pair of wires are the old copper wires. Coaxial cable is a thick cable that is used for cable TV connections and all that, if you have seen. And fiber optics is what you're using nowadays, the broadband connection. I hope you know the thick fiber optic wire with 8 wires inside them, right? That is what is the media. So for either you have to use wires to connect one computer to another, or you can use the wireless path. So you have covered 3 things here. Terminals, which are nodes to which you can connect computers, printers and all that. From one computer to another computer, how will they be connected is discussed based on the wire or wireless media. So 3 items are covered here. What are those? Terminals, computers and peripheral devices, telecommunication channels. Moving up to the next item, here we are going to talk about telecommunication processors. Okay. Now the fact of the matter is, where will you plug in the wire? You have wires on both ends. Where will you plug in the wire? So we need something called as telecommunication processors. The telecommunication processors here, we need to understand, are network interface cards. Network interface cards. This is where you can plug in the cable. Network interface cards, 1. And 2, you have modem. Network interface card, modem, multiplexers, and internetworking devices. What are these internetworking devices? How are these working? All these are some of the points that we need to understand. What is a right? So one second, guys. So okay, so network interface cards, modems, multiplexers, and internetworking devices. All those are the 4 things that we need to probably understand here. So the fact of the matter is, modem. What is modem? Modem, guys, I'll give you a technique to remember what modem is about. See, please understand, this question has been asked so many times in the past. What is a modem? Could be a short answer question as well, possibly. Modem is something called as modulator demodulator. So what exactly is modulation and demodulation? Modulation and demodulation. I'll give you 2 keywords to remember here. I want you to remember these 2 words: add and damn. So what do these words mean, add and damn? The add and damn, I just use them as an abbreviation to remember. If I am converting analog, okay guys, I'm going here, analog signals to digital, it is called as demodulation. ADD, analog digital, is demodulation. DAM, that is if you are doing digital to analog, it is called as modulation. The abbreviation for modulate and demodulate is what modem is. How many of you know this in the past? Huh? If you have not known, guys, this is the logic. So please do not by heart anything blindly. Everything has a logic. Go comfortable, go coolly, and try to understand what these topics are being dealt with in. Understood? Okay. A lot of guys coming in. I hope you are catching up where we are. So do not worry about it. I think if you can go back on it, we will always be able to catch up. Don't worry. Okay, so that's going good, right? I hope everybody is understanding what is going on. So we have the telecommunication process NIC, modem, which is modulating and demodulating. See, the twisted pair of wires in the past, they can carry only data in electronic current form, right? And when you talk about modem is a device which can convert analog into digital. So computer can understand only digital. These wires can bring in only in analog. So that conversion analog to digital and digital to analog is what is done by the modem device. Then talk about multiplexers. You talk about multiplexers. Multiplexers are devices that when they are receiving signals from multiple number of devices, they bundle that signal into one and send it to another device on the other side, which is also a multiplexer, which will again split the signals and send it to all the others. And there are 6 internetworking devices, right? What are the 6 internetworking devices? The 6 internetworking devices are bridge, a repeater, gateway, right? Then we have hub. Hub is a extension device. Like when you want to add more number of devices, you will put a hub and then had. Then we have router and a switch. So switch, router, hub, bridges, repeaters and gateways. These 6 are called as internetworking devices, and these 6 will fulfill the job role of hub will help you extend more devices. Router is the device we use for Wi-Fi signals in the house, right? Repeaters, when the speed comes down, repeaters will amplify the speed and send us up. And then of course you have gateways, right? Okay, somebody is asking hub, switch, repeater. Please explain. Never understood those concepts. I'm explaining that only. Okay, anyways, don't worry. I'm going to take a fresh place to do that. What are those? You need to always understand. See, these things are very important in terms of your understanding. Hub is basically a device where you have multiple ports. It's a multi-port, which one you can say, port multiply device. So it has so many number of connections. Like say in your router you have 4 ports, right, to plug in. Like that your hub has a multiple number of ports. You talk about a repeater. What happens with the repeater? Let's say for example a wire is there which is carrying a network signal. When you keep extending the physical length of the wire, speed comes down. So what we do is after every few meters we'll install a repeater. Now what will the repeater do is to amplify the signal again and then again send it with the same speed. So that here the main network center is there. From there we have connected wires. As the physical length of wires exceed a particular distance, they slow down. So wherever they are slowing down, we are always trying to install a repeater so that it amplifies the signal and sends it out. Switches are something that will help you hop from one network to the other. Bridges switches will help you switch between the networks from one LAN to the other. Bridges help you hop from one network platform to another network platform. What is the other one? Gateway. Have you heard of gateway? Now, like say you generally use it for payment gateway. Now, why do you say payment gateway? Because see, you're making a transaction on Flipkart. You're on a Flipkart's network. But when you want to make the payment, you want to go to MasterCard or Visa, through the gateway. Make the payment elsewhere and come back to the merchant site. The merchant site is not accepting the payment. So a lot of people have this doubt that what is a gateway. A gateway is something that enables you to go through, make the payment elsewhere and come back. It's not only for payments like that. So if you're on a particular network space, you want to go elsewhere and come back to the network space, you use these gateways to help you hop here and there. Okay, so I hope your name says it is sharing is caring. Okay, so if at all sharing is caring, and I think I did share, so you tell me what it is. So hubs, repeaters, bridges, gateways, these 6, these are all called internetworking process. And the last thing that we need to understand here again is about the telecommunication software. Telecommunication software. So all the networking actions, whatever has to be done, whatever network actions within software will take care, like bandwidth management, capacity monitoring or capacity handling. That means which power to allocate where, when which network should be allowed, when the load, and then also there is something called a load balancing. When lot of people start working on the net, how do you go about it? So all these are some points that are handled by the software. See, if all the hardware, let me go back here, if all the hardware is there, where in here, if all the hardware is there and you are not able to, this is the entire hardware setup, so you can't see the software, right? If the entire thing is there here and it is not able to kind of work, because if you simply bring all the hardware together, it's not going to work, right? So this is the basic idea. For the entire setup to work, you need to have a software. Okay, so terminals, telecommunication channel, telecommunication processor, and operating system, and the printers. This is exactly what you need for you to understand and work about the components of network. Generally, about the guided media, unguided media, questions have come in the exam, right? In the past, questions have come in the exam about guided, unguided media. Questions have also come in the exam about what are the functions of a network operating system. That question has also come in the exam. So, and then of course they did ask a question about the internetworking process. Modem, multiplexer, all are 1 mark questions. They've been asked in the past. So, clear? So, which is what I am looking at here as the first topic to be dealt with, and I hope you all had clarity with that. So let me now break it down through classification of networks. The next topic that we are dealing here is about classification of networks. Okay, and we'll have a breakdown here. Network classification goes in 4 patterns. What are the 4 classifications of network that you talk about? Do you have any idea? You can as well do it even before I do. Networks classified based on area, networks classified based on function, networks classified based on ownership, and networks classified based on media. I hope you know what comes under each of this categorization. I don't think we need to really worry about that. In the past, area classification is what? LAN, that is local area network, metropolitan area network, and of course wide area network. Then talking about function based classification, we have a client server architecture, we have a peer-to-peer architecture, and we have multi-tier architecture. Somebody asked for it, I will explain, don't worry. Multi-tier architecture. Then ownership based classifications, we have again 3: public, private, and a virtual private network. So LAN, MAN and WAN, client server, peer-to-peer and multi-tier architecture, public, private and VPN are all about the ownership based. Media based, we already discussed. We have 2 types of media based. Where you use wire, they call guided. Where you use wireless, they call unguided. So this stuff I think in the previous slide itself made it very clear about this. Okay. So guys, if it's going to be based on the area of coverage, then it is about the 3 things that you're looking at here. That is all to do with LAN, MAN and WAN, local area network, metropolitan area network, and wide area network. These are some of the classification based on their area wise classifications. And when you talk about local area networks, it covers about small area, maybe like a building or so, and the speed is very high. When you talk about metropolitan area network, it covers about city, like say 40 to 50 kilometers of range. And when you go about wide area network, they call going cross country and all that. Cross country and all that, that's what is about the area based classification. Then let me talk about public. It's something about open to everybody, right? Example, internet is a public network, open to everybody. Private is restricted to an organization. And virtual private network, this could be a question in the exam, guys. A virtual private network. So what about a virtual private network? You need to understand that VPN is nothing but a public network. It's a public network with use of security measures made to behave like a private network. So it's not really a private network. See, if you want to buy a private network, it's very costly. So you buy a public network, restrict it through firewalls and password, and make it look like a private network, which is what will be called as a virtual private network. Okay, and then if you're going with the client server thing, you have one client and you have one server. The client is the one who is asking the question. The server is the one who is responding to those questions. So there is one-to-one connection. There is one server or multiple servers. There are one client or multiple number of clients, and the interaction between them is amazing, right? If the server fails, then none of those clients can connect within each other. But if one client fails, the entire server setup does not go down. That's the best part about this. VPN example is intranet. Intranet is a very good example of VPN. You know, why is intranet a very good example of VPN? Because lot of companies, they can't afford to have their own intranet by buying leased lines and connections. They're very expensive. So what they do, they'll buy the normal, Reliance, Airtel or Act connections, whichever are available. They'll buy that only. But once they buy that, they'll restrict that network only within their organization. So it's a public network, but it's made to behave as if it's a private network within the organization. They don't allow outsiders to connect to it. Only organization personnel can be able to connect to it, which is making it, giving you a feel like it's an intranet only meant for the organization, which is. So it's actually not a private network, but it's made to look like a private network. That's why intranet is a good example of VPN. I hope that clarifies your point. Okay, so that was, what I was explaining was client server. Then I'm also talking about peer-to-peer. What about peer-to-peer architecture? Here, no server, no client. Every computer can act as a client and server. Okay, so the client server model and the peer-to-peer model are quite different. The two things on opposite sides. Client server. So there is a central server and there are multiple number of clients and even more. So this is a server architecture kind of a thing, wherein if you are talking about a peer-to-peer architecture, there is 1, 2, 3, 4, 5, and all of them are connected to each other like this, right? So this is a peer-to-peer architecture, and this works only when less number of people are there. If many number of people are there, then you don't go for a peer-to-peer architecture, you will go only for a client-server architecture. So these are all clients, this is the server. But if the server collapses, no, entire thing will collapse. Now, generally the one who is asking the question, he is called as the client. So client is the asking person, server is rendering the service. Now, irrespective of what the situation is, whoever does bulk of data processing operations, whoever does bulk of data processing, they are called as fat. So if the server does more work, then it's called a fat server. The client does more work, it's called a fat client or thick client. So in this point, you need to also know about who is a fat or a thick client. Fat client or a thick client. Opposite obviously will be a thin client. When the thin client is there, then it will be a thick server or a fat server, because if client is not doing more, then server has to work more. If it's a fat or a thick client, then obviously it will be a thin server. That means server will only be used as a storage device, not much of work to be done. Understood? So this is about the architectural part. Now, what about this multi-tier architecture? See, we have client, which is one tier, server, which is one tier. Server generally stores data, client generally raises the question. Who is doing more of these processing? We call them fat. Now that is clear. Sometimes the client end up doing more work, sometimes the server end up doing more work. But now I want an equitable distribution of workload on everybody. So how do I go about it? That is where you get in multi-tier architecture. What is a multi-tier architecture? So here in client server, how many tiers you have? 2. But in the multi-tier, it's more than 2. That means you will have a presentation tier. The presentation tier absolutely belongs to the client. Okay, so you have a presentation tier, this belongs to the client. And then there is one data tier wherein all the data is stored. So you have a presentation tier at the client end who's raising questions. You have a data tier on the other side where entire data is stored. But data tier can't obviously respond, it's a dummy layer. Presentation tier is the user, he'll only ask the question. So therein, for this particular case alone, that is in the multi-tier architecture, here we are introducing something called as an application layer. This layer, this is what makes it a multi-tier architecture. This is tier number 1, this is tier number 2, and this is tier number 3. The more the number of tiers, you want to add a multi-tier, this is 3-tier architecture, right? The most commonly used multi-tier architecture, the same line will be there in your book, you can refer. The most commonly used multi-tier architecture is the 3-tier architecture. You get what I'm saying? So which is what is the tier architecture. Sir, what about 4-tier architecture? Yes, you can add 4th tier also, but what will be the 4th tier? It will again be another application layer. So that you have more application layers, it processes more and more faster. But anyways, you will not have 4 and 5 and all. Generally, the commonly used one is 3. Okay. So yeah, that sums up the discussion on the classification of networks, where you were just talking about going back to the classification. We have area based classification, we have function based classification, we have ownership based classification, and we also have media based classification. LAN, MAN and WAN are distance based, public, private, VPN are ownership based, whereas your client server, peer-to-peer and multi-tier are based on the tiers, and guided unguided are based on the wires. So I hope you have clarity on this concept as well. What are the purpose of application layer? See, application layer, that's what I'm saying. Catch up once again. That is what I was just explaining, right? See, earlier either the client used to do more work, so he is called a thick client, and server used to not work much. Either ways, client used to not work, a server used to work more. So in either of these cases, they are called fat client or fat server. But I don't want either of them to be fat. I want an equitable distribution. So now in the presentation tier, client will only ask the question. In this data tier, they will only store the data. Application layer will do the entire processing. Okay, that is the reason why application layer has to be done. So the purpose of having application layer is also for that enabling the processing. Understood? So guys, like we discussed, this is topic number 2 for our discussion. So I hope in the last half an hour, whatever we discussed, these 2 topics are very much clear to you. So I'm going back to the schedule that we picked up in the beginning of discussing these topics, wherein so components of network, you have 5 components. I hope you're clear now. Classification of networks, you have 4 classifications under which each of them, I hope you're clear, right? So, and the next concept that I'm going to deal with is the network topology and transmission. Guys, do not worry, there can be one more session on chapters 4 and 5. Somebody is asking, so please revise 4 and 5 fast mode. If you want a fast mode revision, it's already available. Today I've been trying to explain these topics because a lot of people have no clarity on these topics. So I'm trying to explain them in detail today. You want fast mode, you can look for quick revision of IT. 2 videos are there, all 5 chapters are revised very quickly. I'd request our admin to share the links if possible. Let me see if we can share it up. Then the quick revisions of IT. Okay. So sharing is caring. No, I don't know, that's a very odd name to call out, but yeah, whoever you are, don't worry, those 2 chapters, all the 5 chapters, quick revision is already there. Please do search quick revision of IT, you will get it. And today and the next session's agendas here is about giving more clarity to people so that they understand the concept deeper. Other guys who have been watching from quite some time, probably can you share your feedback now? So, come on, I want you guys to come out and say Are you, I mean, is it going good? You're understanding? I mean, is there any doubts? Guys, this is a live platform. Nobody knows, or nobody is really bothered about who you are. So do not hesitate to ask doubts. In the class, you might always been thinking that, what will the person sitting next to me think? What will the lecturer think if I go and ask? What will my faculty think? So in the process of you thinking what they will think itself has killed your whole thought. So do not resort to such things. You can have a doubt, no problem. Doubts are pretty common, right? You can't doubt yourself. That's the only question, and that doubting will happen in the exam hall. So guys, I've been telling this so many times. So if you have doubts, please do share. The live chat option is meant for that purpose only. Your doubt could be the doubt of so many people. Now, despite telling all this, still a lot of people don't open their mouth. So here I'm not even going to see your face, and no criticisms about what doubts you asked. Understood? So simply, if at all you have, okay, very good. So do you need this motivation? Then only you will come up with doubts. Somebody's come up with one. The other guys, okay, somebody saying it's a super class. Very good. Thank you so much. You have a lot more left in. Difference between a terminal and a computer. See, terminal is basically a point. It's a node where you can connect anything. Okay. A terminal is basically something where you can connect. Computer is a device. Okay. Printer can also be connected to a terminal. So many peripheral devices are there which you can connect to a terminal. So terminal is a space wherein you can connect these devices. Understood? So yes, that's the case. Okay, Balasubramanian, my request is to prepare presentation instead of writing in live session. Balasubramanian, fantastic. If you have watched our previous live sessions, I always come with a PPT, right? Today, there are so many things that I obviously don't want to give them as reasons, but I was pretty much into something else. But yeah, today I think we should do this. But again, with a PPT, it might sometimes get into very theoretical. So I might not be able to explain it so freely. But yeah, sometimes doing freehand also works. But yes, point taken and point always noted. Please do go and watch the previous live sessions wherein we have done the 7 series and other audit concepts. Okay. So please give memory technique for network security like add and damp for modem. Sagar, network security, you don't need to have techniques. I will explain you now. You will understand. Don't worry. Okay, if you understand the concept now, you don't need techniques. For not making mistakes, I gave you add and damp. Don't worry, we will get back now. Okay, so now a lot of people are coming up, so you need some kind of motivation to push you through, saying that what will somebody think. All through your life you have been thinking that only, what will somebody think if I have a doubt. Okay, let's move on, guys. Yeah, other doubts I am taking up, don't worry, guys. Okay, so right, so 2 topics were covered. We're moving on to the third one. I'm here to talk about network topology. Don't worry, guys, you can keep sending your doubts in the chat. I will look back at that now. Network topology. Okay, quick revision. Come on, tell me how many topologies are there. Obviously, by the time you type, I will finish writing it. So what are the 4 types of topologies here? You have a star topology, you have a ring topology, you have a bus topology, and you have a mesh topology. Let me go on with these, guys. Star topology is just like what we discussed in the client server model. There is a central computer, okay, to which all other computers are connected. So this is one way of getting your network configured using a star topology. One central server and all the 4. Very good. Somebody is fast in typing. Okay, star. Next one is ring. What is the ring topology? This is more like, I showed you a peer-to-peer diagram. It's like that. Why? Because this is computer 1, this is computer 2, this is 3, this is 4, and this is 5. Now, how are they connected? 1 to 2, 2 to 3, 3 to 4, 4 to 5, and 5 back to 1. Now, the best part about, or sometimes the worst part about a ring network is that it can flow only unidirectional. No computer there is central or something. Now, like say if computer 3 fails, okay, let's say if computer 3 failed here, okay, when computer 3 fails, the entire ring it can't travel. So that will be a problem there. But otherwise, each one of them are an individual computer, all of them are connected in a unidirectional manner. But when you add new systems to this, now like I want to add new to this one, it's quite easy. But here again the same catch, if the central one fails, the whole thing will fail. and here you have 1, 2, 3, 4, 5. It has to travel through the entire node and come back to 1. That's unidirectional. Talk about a bus topology. Bus, like you know, is a bundle of wires. So there is a single wire flowing through in the bus topology from the network center to the other. So then what you will do is to pull out other wires in different manners from this. So we have another computer here, another computer here, another computer here. But you know what is the problem? As you extend the length of the bus, that is the wires, the speed might slow down, or as you add more number of peers, then also the speed will come down. But some time back I taught you about something called as a repeater. Yes, definitely what you can do is to install a repeater here and then again continue to increase the wire. So that's the point. Moving up next is the mesh. What about a mesh topology, right? Let me say we have 5 again. So this, once again, no criticism, but these things I can't do in a PPT. See how easy it's for you to understand and connect. Now what about a mesh topology, wherein each node is connected to all other nodes in the network? Okay, so 1 to 2, 1 to 3, 1 to 4, 1 to 5. Then again 2 to 3, 2 to 4, 2 to 5, 3 to 4 and 3 to 5 and 4 to 5. See, this is something called as a fully interconnected mesh model, wherein everybody can connect, and these are not very common because you see the amount of cabling there. Okay, I could do it easily because there are only 5. What if there are 10? I mean, the permutations you can come, so much wire will be used. But unless it's a military installation or unless it is something very serious, you don't really need this kind of a very complicated connection. So star, ring, bus and mesh, or star, bus, ring and mesh, 4 topologies. I hope you understood, and I think it's giving you clarity. Oh, a lot of questions coming in again. Sir, you're covering important topics. Good, sir, for this lecture. Okay, thank you so much. Right. Please revise thoroughly on chapter 4 and 5. Don't worry, we will do chapter 4 and 5. Even today I don't intend to start chapter 4. I'll give you a complete picture of networks chapter. In the next live session, we'll do 4. Don't worry about it, guys. Right. Prashanti, please explain cryptography and cryptanalysis. Next topic, network security, where we are going to wind up. We will see that. Hi sir, live session is awesome. Okay, thank you so much. So guys, did you understand this network topology? Good. What are the next topic that we are going up to catch is the concepts of transmission. Now, network transmission. Okay, this is a very important topic because you have so many subtopics. Network transmission. Okay guys, you just have to excuse me for a second. Okay, we're back. Don't worry about it. Okay, just a small glitch. So yeah, moving on to network transmission, guys. We have 4 topics to be dealt with in here. Okay, so if I'm really talking about these 4 topics, all that I need to check once. Just give me a minute. Yes. Okay, so that is done, and okay, we're back. So you're talking about network transmission. We have transmission. First topic, we have transmission technologies. Then we have transmission modes. Okay, and then we have transmission techniques. Okay, yeah, that's it. Yeah, transmission technologies, transmission modes and transmission techniques. Let's go with this, guys. So now if you're talking about transmission techniques or technologies, we want to break this down. Serial and parallel, synchronous and asynchronous. These are the 4 technologies that you use for transmission. Okay, so serial, parallel. Serial means, now let's say every byte of an information, 1 byte of information is having 8 bits, right? If 1 bit travels after 1 bit, okay, one after another, this is a serial. If all the 8 travel together, okay, what did I exceed 8? Okay, whatever, right? So all the 8 travel together, then it is parallel. Now if you look at using a fiber optic wires, all 8 can travel parallelly. That's why this is called what? A parallel technology of transmission, and this is a serial technology. Serial, parallel. Then synchronous and asynchronous. Synchronous means wherein the sender, sender, receiver, both these guys are at the same speed. Sender and receiver are paced at the same clock speed, so that as soon as the sender sends, no receiver can receive it. But an asynchronous model is not like that. Where in asynchronous model you have start and stop bits. Start and stop bits. Okay, so what happens with the start and stop bit is that there is a particular time at which when you say start and then stop, only during that particular time transmission happens. So all 8 are traveling together is parallel, one after another is serial. If sender and receiver are paced at the same clock speed, it's called synchronous. Asynchronous is about where you have a start and stop bits. Now like say we are online instant messaging, all synchronous. You send a WhatsApp message, if the other person is online, he gets it immediately, right? So synchronous transmission, we both are on sync, right? Moving up next, you talk about modes. Okay, the 3 modes right here, we talk about them, 3 modes. What are the 3 modes? First one is simplex. Okay, simplex is a one way, okay? Keyboard to computer, mouse to computer, computer to printer. So there's only one flow. You never expected anything to dump in the printer, no? From printer it won't go to computer, or from computer nothing will come out from mouse. I mean, like, looks scary, right? If you're holding a mouse and something is coming out. So mouse to computer, keyboard to computer, computer to printer, where there is a one way, that is called a simplex connection. Then we have a semi or half duplex connection, which is the best example of a half duplex connection is a walkie talkie. The police use, right, the walkie talkie, or the event guys, event managers and all. See what happens, police or event guys, why do they use that? Is because they need clarity. What do we lack in your phone? Now like, why can't 2 people talk on the phone? Because both of them can talk simultaneously. I can talk, you can also talk, I will also shout, you will also shout, nobody will understand anything. So in order to avoid that, what do they do in a half duplex connection is I press a button and talk, and then my communication goes to the other side. Then they press the button and they talk, it comes to me. So which means what? Bidirectional communication is possible, but only one at a time. That's the best part about half duplex. It is bidirectional, but only one at a time. Example is walkie talkie. That's why the police finish and say over, so that the other person can now start talking. Which means, like you're telling that a thief is running away. You are shouting, they are also shouting. Nobody understands, the thief gets away easily. So that's exactly why what we do is, for clarity's sake, only one person can talk at a time, and then he'll talk, and based on that it goes in. Understood? Simplex, half duplex, and the full duplex is your cell phone. Full duplex is a telephone or a cell phone. Bidirectional and simultaneously. So big difference between semi duplex and full duplex is what? This is bidirectional, but only one at a time. This is bidirectional and simultaneous. You get what I'm saying? So that's what is the point that is discussed here in this case. So that is how you need to understand about these particular cases. Okay, so simplex, half duplex and full duplex is about, full duplex is mobile phone. Perfect. Okay, Lava, sir, what is a bridge? Give an example. Okay, we will get back to that. Okay, we are in the middle of something. Lava, don't worry, we will get back to that. Devika, sir, I studied IT many times, but I forget while writing exam. Please give me your valuable suggestions. Devika, don't worry, study the concepts. An exclusive session is coming up for that. Don't worry. Then network transmission techniques. Okay, Kavya, packet switching is coming. Why are you in a hurry? All of you are, you guys had dinner. If you guys had dinner, have patience. I didn't even have my dinner, so don't run. We are coming to that topic. Okay, cool. I hope you understood technologies and modes. Let's move on to techniques. What are the 3 techniques here? Circuit switching, message switching and packet switching. Okay, circuit switching is what you use in your home phones, like landline phones. They have a knob on which you place the receiver, right? It's a switch. So when you pick up that communication line, an outgoing line is established so that you can talk to somebody, you can dial the number. Same way you reach out to the other person, they pick up a communication line, so as an exclusive circuit between you and them. You talk to them on a a landline phone. In the past you used the BSNL phones. When somebody else is calling, you won't get waiting signal and all in that. You will encounter an engaged signal. Why? Because already your receiver is up. Even sometimes what happens if you forget to keep the receiver properly on the switch is on. That means you will let communication in, so you are ready with an outgoing signal. So that is why incoming signal doesn't come. So you understood the logic anytime. When you don't place the receiver on the phone, why don't you get calls? It's because the switch is open. When the switch is open, it's an outgoing communication line. So there's no incoming there. That is the same thing while you're talking on a call. Okay, but nowadays we have, of course, mobile phones and all that. So we have call waiting and other facility whereby you can lift this call, put other person on hold, talk to the other person, come back on hold. You can take both of them on conference. All this is happening because it's all in radio waves, and it's of course using packet switching. We will see that also. So I hope you understood. Circuit switching is the olden day landline phone. Message switching is about your kind of a text message wherein there is a server. You send a message from one of your portals, it goes to the message server, and from there it goes to the other recipient. That is about message switching. Now coming to packet switching, this is an important short answer question. So I'm going here to deal with packet switching. Yeah. Okay. Packet switching. What about packet switching? Let's say, okay guys, concentrate here. What is the packet switching? A lot of people write crap when you ask this question in the exam. It's come so many times in the exam. It's a small and simple one. Check out. So this is a data piece. Okay. Full data, whatever you are willing to send. Now this is from the sender's point of view, this is the data. There is another fellow here who is the receiver. Okay, he has to receive the data. Now he has to receive which data? Whatever data you sent, he has to receive the same data, right? But how does the transmission happen? Watch out. Packets. So first question is, sir, what are packets? Okay. See, today I'm loving this. You can use fancy colors to explain this stuff. This can't be done on the regular classroom board. Okay, data is broken down into small individual units. These all small individual units, it can be broken down. These individual units are called as packets. What are these individual units called as? Packets. Now, what happens with packets is they can travel in different directions. Each packet knows where to go because each packet has to go here only. All packets, they have the address with them. Like if the address here, it is called as header information. Okay, each packet has the header information. So they have to go in different directions. This is the first packet, this is the second packet, but there's no ordering. Okay, any packet will travel in any direction. And now obviously you can ask me a doubt, sir, if the second packet is traveling in a shorter direction and it reaches first, what will happen? Yes, like that again all the packets will come back here and reach. Then all these packets will reassemble. Remember this keyword, reassemble into the original message and display it to the receiver. That's it. Kavya, that is what is packet switching. You understood? And all of you listening to this, it's a very simple concept. What all did I tell you? Okay. So I'm telling you how many points to write in this answer. You will not lose 1 mark also. Concentrate. Point number 1. The entire data is broken down into small units called as packets. 2. Each packet will have header information. So it travels through the network path. That is wireless. Obviously in the atmosphere, it travels through the network path and reaches the destination. What happens at the destination? At destination, all the packets reassemble. Right? All the packets reassemble and they display the original message to the receiver. Right? Sir, can I add a password in this? Can I add anything else? You can send images, you can send text, you can add passwords, you can do all of that. additional passwords or pin can also be added. 6 solid points. You will never miss a mark. This is a 3 marks question. Write all these 6 points, get all your marks. Alright, thank you sir. I got it. I'm sorry for rushing. No problem. But yes, I was just saying. Okay guys, so this is a packet switching concept. It's a very important short answer. I hope it served the purpose. Okay, then we're going up and then moving on here. So back in on network transmission technologies, modes and techniques. So which talks about serial, parallel, synchronous or synchronous. So and then modes we have simplex, half duplex and full duplex. And techniques we talk about circuit, message and packet. Okay, the last concept for now in this chapter, which I would want to cover in the third chapter, is about the network security concepts. Okay, what about network security? This is also a very important piece guys, the network security in this topic. You know, we have first things we will discuss about threats. Where do threats come from? Right? Then what are the vulnerabilities that affect us? Right? What are the various weaknesses that an organization can go through? What are the vulnerabilities? Then we talk about network security protocols. And lastly, we talk about network security techniques. Network security techniques. Right? Vishal is asking, is it revision or regular? Regular means what? I wanted to deal all these 4 concepts of network in detail. So today's live session is exclusive coverage of those important topics in networks. If you're looking for a very quick revision than this, you already have 2 videos of all 5 chapters. You can get there. The idea of coming live like this is to explain topics in detail so that people have utmost clarity. I'm going to do this once again for IT, maybe for the 4th chapter and the 5th chapter as well. We will, I mean, if at all you guys are interested in, so if you can guys have, all of you have been watching this live session, I've been, a lot of you have been watching, so if you guys can as well share your feedback on what further live sessions you want and what chapters you would like to listen, be it ITSM or audit. All of you guys watching, shoot in your request. Accordingly, I will plan and come across. So let's now for the last few minutes we discuss about what are the network security aspects. Okay. Okay. Going good. Let's go with the green. Okay, threats. Okay, threats, right? We'll go with red. Chalo, see, this is what I can play with. I'm enjoying this. Okay, what are the 4 threats? We have internal threats coming up from our own employees. Because see, you trust your employees very much, but you didn't give promotion. That fellow is disgruntled. He didn't get increment, so he's irritated. So that is the thing. Our own internal employees can do a great damage. Obviously, people are waiting outside to do enough amount of damage. External, that is hackers or competitors, those guys are anyway there. So threats come from 2 sources, internal, external. And threats are of 2 types. You know what the 2 types of threats are? Right, let me go with the same. Right, there's structured threats. Structured threats come from those people who are well trained, who are capable of writing hacking scripts. These guys have degrees in ethical hacking. These guys have studied about hacking. These guys absolutely know about hacking. And these are the guys who are hired by, you know, the national intelligence agencies, RAW, cybercrime department. These guys, they actually have degrees and they are well-trained professionals. So, structured threat can come. Then unstructured threats. Unstructured threats can come from anybody who's not a trained hacker and all that. But, you know, there are some people who go onto the internet and type in Google, how to hack my neighbor's Wi-Fi. How to do, how to hack or how to know about my friend's email password. These are people who Google up all these kind of stuff, and just through so many freely available tools are there on the internet, through using them. They are not trained hackers or they are not trained script writers and all that. But these guys learn something freely available on the web and they do it. So those guys are called unstructured. So don't Google up that stuff like how to hack my neighbor's Wi-Fi and all that. Understood? So 4 kinds of threats here: internal, external, structured and unstructured. Okay, that could be a question in the exam. That has been a question in the exam in the past, so you can very much focus on that. Okay, moving up next, vulnerabilities. what are some of the vulnerabilities? You know what is a vulnerability basically? Vulnerability is a weakness in system safeguard. First thing, it's a weakness. So then what are all the weaknesses that you generally look out for? Right? Vulnerabilities, the very first one could be a software bug. Software bugs. Those are small errors in coding and programming. Right? Then we have something called as trusting untrustworthy information. Trusting untrustworthy information. That means something that you shouldn't have accepted, you accepted. Like say sometimes people click here to win, they go and click that. No, that's not something that you are supposed to click. But it's a very lucrative thing that people are, something is going to be won here, let me go and check this. It's kind of a program which is malicious, which can be harmful, right? And you trusted that untrustworthy information. And you know what is one more weakness? Some people leave the default passwords. Now like say you bought an application, that application has a default password called password. You left it like that only, you didn't change. Now the whole world knows what the password is for that. So insecure default configurations. Most people leave their password with default configuration. They're very insecure, very dangerous. Then timing windows. These are like, some people gain access through temporary programs. Like there is a temporary program through which they entered into your computer, in the communication line, and they try and attack the other permanent programs. So the timing windows, like they make sure that there is a particular weak program through which is even a temporary program, which they can just, it's like a gate for them. They just have to enter into your system through that. Then after that you might destroy the program and all that, but their presence will continue to be there, and that can cause damage to the system. Software bugs, timing windows, trusting untrustworthy information, insecure default configuration, and the biggest vulnerability is our own end user. Why is he a big vulnerability? Because this fellow, he is not trained sometimes properly. And some end users, what they do, they end up, they have 4 or 5 passwords to remember. They can't remember all of them. So they'll write the user ID, password on a paper and stick it on their desk. Now how horrible is that? How can you do that? Anybody coming in, like you're telling the thief, "Arey, please don't get disappointed. See, my passwords are here, take it." What are you doing? So these people, they start writing down the passwords in places which can be easily stored. And the end user should be trained. Some people save files on their desktop. And they save files on the desktop with a folder name, very confidential. Now when the thief gets access to your desktop, the first thing, at least he got access, but he doesn't know where the file is earlier. But now you very clearly are directing him, saying that, see, this is my very confidential folder. If you want anything serious, touch this. I mean, like, are you a very kind-hearted, generous person that you are allowing the thief to, it's like some people think, no, the thief will be feeling very bad. He's not getting what he wants. So let us give it to him. What are you actually doing there? Some people save important stuff on the desktop saying private and confidential data, do not open. These are not names how you are supposed to. Do not open means I have all the curiosity in the world to open that one. And you will write passwords. And some people have the all the passwords listed in a file and they save it there. And then they will keep one file name for that. My passwords. Boss, anybody getting to see there, they'll have the whole of you. So apart from all this, the biggest culprit is our end user. Understood? So these weaknesses are there in the system. They have to be somehow protected. So how do I protect them? Is about again a simple logic. I can install some network security techniques or network protocols. When the protocols, what are protocols? Set of rules. So before I go to protocols, I hope you understood internal, external, structured, unstructured, and all these vulnerabilities, right? Protocols, a set of rules. We have 4 protocols, guys. First up, we have a secured shell protocol. That means, you ever been to the seashore? You saw a shell. Shell has what? A very hard outer cover, and it's hollow inside, so that nobody knows what's there inside. So there is a very hard outer cover, so that what is happening inside that, nobody can see, which is exactly what is the concept of the secured shell, which is an internet protocol whereby on the network, if any activity is being conducted in the secured shell protocol, no outsider will be able to see it, because everything that happens inside a secured shell is encrypted and protected. Get that? That's how the secured shell layer works. Then whenever you want to make payments or whenever you are on websites which need to, payments and all to be made, look out for this domain, HTTPS. That's a secure hypertext transfer protocol. Understood? Secure hypertext transfer protocol. It's a very important one for all the internet. You will get a lock symbol, to be, if I have to tell it in your language, on the address bar there will be a lock symbol which says that yes, this is a secured portal. So on all payment, next time you shop on Flipkart, Amazon, when you jump to make the payment gateway, see there, whenever or while you're paying your exam fees, you should have seen it, right? The protocol that you're using for the internet site, the website, it is a HTTPS. It's a secured hypertext transfer protocol. Then the next one is a SFTP, secured file transfer protocol. Secured file transfer protocol is something where, like in an email or any portal through where you're sending your files, that protocol is meant to be a secured file transfer protocol. And the most important of all these, which is used for payment gateways and making payments, a secured socket layer. Next time when you make a payment gateway login, you see it will be showing there as an SSL login. An SSL is a secured socket layer. Again, what happens inside the socket? There is a protective outer cover. That is what is the socket. Now, like say there's an electric wire. If you go and touch the electric wire directly, what will happen? Obviously there's a shock that you're going to encounter. But I don't want that shock to encounter. I don't want to know that electricity is passing inside. What will I do? Same wire I'll put inside a pipe. So even if you go and catch the pipe, you don't know that electricity is passing inside. It's absolutely something what's happening inside you don't know, which is exactly what a socket layer does. So in the socket layer, whatever transmission is happening inside the socket layer, it is a very protected and encrypted transmission. So these 4 protocols are used. You need to be very clear about these 4 protocols: secured shell, secure hypertext transfer protocols, secured file transfer protocols, and secured socket layer. Got it? So threats, vulnerabilities and protocols, and the last topic for right now is about this network security techniques. Okay, let me go with the network security techniques. Some people telling something. Okay. We are very much interested in it, so thank you. Your words are getting absorbed in my mind. Very good. Thank you so much. Sagar says, nice explanation for end users. End users, I like these people, these end users like us. We end up doing those mistakes. Okay, so moving up to the last part of the discussion here. Let's go with the blue again. What are the 4 techniques? First one is called a firewall. What's a firewall, guys? A firewall is a protective barrier, right? A firewall is what? A protective barrier. In terms of what a firewall does, like the internet is a very vulnerable space. So many websites are there which keep sending information to us. So when anything is coming from outside to our device, okay, the firewall first blocks it. It stops there. And once it is stopping there, it will then decide whether to allow or to deny. That is the option of the end user. But a firewall is a blocker, that will block all the content that is coming from other websites or other networks. A firewall will block it, and then the user has an option to allow it to pass through the firewall or deny it. Now the option is absolutely yours, whether to allow it or deny. So what is the firewall? It's a barrier between our secured communication and the whole unsecured communication like the internet. That's about the firewall. 2, you have a message authentication. Is a mechanism where every message that is sent on the network is authenticated, how it is done and what the message is, whether it is to be sent or not. See, nowadays people are, if you post some irrelevant content, or if you're posting some abusive content, Facebook or Twitter takes it down. Like those messages are not authenticated to be passed up, right? So that is message authentication. And then if you're also looking at the third one has got something to do with okay, just let's slip my mind. Firewall, message authentication. There is something called as site blocking. Know what is site blocking? A list of blacklisted websites whichever you don't want your employees to access at the workplace. Like say you don't want them to access Facebook, you don't want them to access Gmail, or you don't want to access YouTube or any torrents or all that. Otherwise, if you give free access, some people may open up to websites which publish some explicit content which is very objectionable, not to be opened in public places. Such sites, if at all you feel are not supposed to be put up, then all those sites, the list of all of them can be blocked up very clearly. And the 4th one is called an IDS, intrusion detection system. I'm going up to explain you. Okay, you guys are liking this, I guess. Some good positive feedback coming up. Very nice. Okay, I'm very happy about it. Yeah, let me finish ideas, then I'll come back to the chat. Intrusion detection systems. What are intrusion detection systems? See, this is my host system. This is another host system. Okay, watch out. A lot of people don't know how this works. Okay, so concentrate here. You might as well understand. So from one host system to another host system, you're sending data. Okay, this can happen through a communication line, be it wire or wireless. Okay, now tell me, if I have to attack you, right? If I have to attack you, where are the weak spots that I can attack you? I can attack you on the network. That's my first vulnerable spot. Network. On the network I can attack you. That is on the wire or wireless medium. I can attack you there. I can attack you at the host. Right? I can attack you at the host. I can attack you on both the places. Right? 1 and 2 together. That is both places I can attack you. Or a very vulnerable place, I can attack you here just before you enter the system and after you finish transmission. This point is called what? Node. It's the network node to which the computer or anything is connected. Now, so you can see these 4 red areas, which are the 4 weak spots. Sir, then what do I do about these 4 weak spots? How do I go about them? If you believe somebody can intrude you on the network, for them you install something called as NID. That is a network intrusion detection system. If you believe that they will enter your computer or your system and do damage, then there is something called as HID, which is a host based intrusion detection system. So the host based intrusion system is inside the host system. NID is on the network. Then covering both is called a hybrid intrusion detection system. Covering both is called what? A hybrid intrusion detection system. And if at all somebody is ready to attack you on the node, then you need to install something called as NNID, Network Node Intrusion Detection System. These are the 4 types of intrusion detection systems: host based, network based, hybrid, and NNID. Right? I hope this picture is clear to you. So guys, that's it in terms of what an intrusion detection system is. And let me also explain you one last sub concept so that you can go peacefully. That's called cryptography. Somebody has asked this also in the past, right? What is the concept of cryptography, or what is this? Right? Cryptography is the entire act of converting plain text, that is whatever is normal, into ciphertext, so that the ciphertext is absolutely meaningless. This activity of plain text into ciphertext is called as encryption. Okay, this converting plain text into ciphertext is encryption. Doing reverse cipher back to plain is called as decryption. Okay, conversion of plain text into ciphertext, encryption and decryption, these 2 parts. The study of both encryption and decryption, the art of getting these done, right? So doing encryption and decryption, the art of doing that is called cryptography, the entire thing. If you study the whole thing, this is called as cryptology. Like logy is a study, right? Biology is a study of human life, like that. Cryptology is a study of encryption and decryption. Cryptography is about doing encryption and decryption. Now, from converting plain text into ciphertext, you will have a logic of doing that. Okay. Likewise, somebody has to break these ciphers, no? Art of breaking ciphers. Art of breaking ciphers. That is called as cryptanalysis. Art of breaking ciphers is called as cryptanalysis, and that's exactly what we're looking at in these terms. Okay, so that's the small concept but very important one. Cryptography is an act of converting plain text, which is the normal one, into ciphertext, which is meaningless, so that even if when data is traveling on the network, if somebody intrudes and captures all the data, they'll capture ciphertext, and to decipher that ciphertext, they don't have the decryption key. It is there only with the other party. So since the decryption key is not there, it becomes very difficult for somebody who hacked the data, the encrypted data, to decrypt. Understood? So encryption is about converting plain to cipher, decryption is cipher back to plain, and the study of encryption and decryption is called cryptology. The art of doing that is called cryptography. The art of breaking ciphers is called cryptanalysis, and the one who does it is called as cryptanalyst. Okay, so that's it from my side, guys, here. Okay, let me quickly get to the chat. If I've missed something, don't scold me. It's been very late in the night, so I've missed one or two of your chats. Okay, if we have anything to catch up, we will discuss that. I think most of you have answered. If at all I have didn't, yeah. And like I said, all guys asking on presentation and tips, separate sessions are coming, don't worry. Somebody in the between said sharing, please have dinner and come, we'll wait. Oh, no problem. Thank you so much for the concern. Keshav Reddy sir, explain the difference between switch and a hub. Switch and a hub, switch helps you to shift between local area networks from one local area network to the other and all that. Hub is just like, like say, if I don't have power source, how I am using an electrical extension box. Like that, when I want to extend my physical length, that time I will be using a hub. But generally from one LAN to other LAN or one network to other network, if you want to hop, we will be using a switch. That is a bigger difference. Okay. Your words get absorbed in my mind. Vishal, thank you so much. You can go with. Davis sir, please revise on SM chapters also. Coming up, don't worry. All of that. Nice explanation about firewall. Okay, thank you. You got it. That's good. IDS concept is very clear, sir. Thank you. Fantastic. Using colors to explain is very attractive and easy to remember. Thank you so much. I think I mean definitely this video you save and keep and share it with the others who didn't. So Lava, fantastic explanation of cryptography. Thank you. And the others saying thank you. All of you doing good. Okay, Lava, so what is a bridge and an example? Bridge, see basically bridge is like, what is a traditional bridge? There's a river on this, there's a river in between. You have a city this side and you have a city this side. And then you have a bridge constructed on the river to go from here to there. Same logic is applied, whereas a bridge is a device, which is you are on one network, you want to hop onto another network. So when you want to hop onto one network to the other, you cannot pass through the same communication line. So what will you do is, see, the fact of the matter is all this takes place in fraction of seconds, which is why we don't go in that detail to break down. So bridge is a device. It will receive all the info from one network. This bridge will help you hop on to another network and that it goes on. So if you can just Google about a bridge, you can see the device, how it is, the bridge. It shouldn't be a real problem, but this is what it does. Helps you hop from one network to the other. Completely different. Not like a, one local area network to the other, what the switch does. No, not that. Like a bridge is completely from a different, like I am using a Reliance connection and you're using an Airtel connection and all that. So we are on different network platforms altogether, right? So to hop up, you have a bridge device in between. So, okay, what about difference in digital signature? I didn't get you. Difference in digital signature in the sense, what are you actually talking about? Digital signature, I didn't get you that question, Balasubramanian. Can you be a little more precise? Vamshi says, hi sir, nice to see you online. Just joined. Earlier I was a student of auditing in Gyan. In the past, Vijayawada, is there any schedule for live classes? Oh, no live classes right now, but anyways. For this live classes you are asking, what coming? I'm coming on YouTube live. Yeah, soon we will release a schedule for September and October as well, so that you guys can have a thing. Kavya, when will be the next session? Yeah, for you guys. So don't worry, we will inform all my future sessions well in advance. Maybe by the early next week, whole of schedule for September and October. At least the tentative schedule of when I will be coming, I will be informing. So, okay guys, so I think it's been longer. If I have not answered any one or two of your questions, do definitely excuse me. In the next live session, we will catch up. And I wish you a good preparation to continue and have a peaceful night, sleep well, and I'm sure your preparation is going up to the mark. We will come back and catch up on all of that. Other chapters also I will see, SM also I will see, as and when possible. We'll do more live sessions to catch up. And of course, if you guys are supporting me like this and if you guys come back with such great feedback, why will I not do it? So we will do it. So for now, I'm extremely hungry. That's the point. Alright, so I will sign off at this point in time. I hope this session did give you a great clarity. We will do chapter 4 and chapter 5 as well. Of course, if required, I will explain the other chapters as well, and we will also do similar sessions for SM. I will see you soon, so stay tuned to our channel. Those of the guys who haven't been part of the channel, please do. See, here I'm not, again, this is not a commercial channel, so we're not saying like, share and subscribe, but of course it is absolutely, you know how difficult this concepts are for some people to crack on their own. I hope how clarity matters to you today. If you have got something better than what you knew before this live session, please do make sure that you expand it to the others, because when you share with them, they'll also get benefited. All that you are doing is, like, I'm not somebody who's really bothered about the number of views or the content. If even the number of people who you were seeing, if you guys are satisfied, are more than good. So it's not for any of that, but do share with others, because sharing is caring, somebody said, and that's exactly what it is for about, right? Thank you guys, you have a very good night, have a good sleep. I will see you in my next live session very soon. Good night guys.